Hello everybody, I'm Suman Matthews and here we will be discussing properties of determinants. This is a part of class 12 mathematics and we will also be discussing board questions of class 12 mathematics which have been asked in the past few years. This channel has math videos for grades 11 and 12 which help students prepare for the ISC CBSE exams. For more videos, subscribe to my channel or visit my page and feel free to send me your feedback. So here we discuss the properties of determinants and learn how to solve problems based on these. So we first come to the few properties. If each element in a row or column of a determinant is 0, the value of the determinant is 0. Here we assume that a student knows how to expand a determinant and the video is more problem oriented. It focuses more on solving problems. The value of a determinant remains unchanged if its rows and columns are interchanged. So here we interchange the first, we have A1, B1, C1, A2, B2, C2, A3, B3, C3. We have taken the transpose. So this is a transpose and value remains unchanged if you take the transpose of the determinant. If any two rows or columns of a determinant are interchanged, the value of the determinant changes by sign. Here we have interchanged the second and third row. So the value of the determinant is negative. And interchanging, this is how you denote the symbol. If any two rows or columns of a determinant are equal, the value of the determinant is 0. Here we have the first column and the third column are equal, so the value of the determinant becomes 0. If each element of a row or column of a determinant is multiplied by k, the value of the new determinant is k times the value of the old determinant. What we are trying to say is if first column has every element k as a factor, so you can take out k and write it as k into A1, B1, C1, the remaining columns remain the same. If each element of a row to each element of a row or column, we add multiples of another row or column, the value of the determinant is unchanged. That is, I can do R1 plus k times R2. So this is same as A1 plus k A2, B1 plus k B2, C1 plus k C2. Coming to questions, prove that determinant of A plus B, A plus B plus C, 2A, 3A, 3A plus 2B, 6A plus 3B, 4A plus 3B plus 2C, 10A plus 6B plus 3C is equal to, we need to simplify it basically. So what we are going to do is we will write R2 minus 2 times R1, R3 minus 3 times R1. So this becomes, the first row remains unchanged, second row is 0, A, and this will become 2A plus B. The 2C gets cancelled. This is 0. 6A minus 3A is 3A, 3B gets cancelled, 10A minus 3A is 7A, 6B minus 3B is 3B, and what is 3C minus 3C? 0. So you get 7A plus 3B here. Now we can expand it, so this becomes A into, how do you expand it? Take this 2 by 2 determinant, A into 7A plus 3B, minus 3A into 2A plus B, minus A plus B into 0, plus A plus B plus C into 0. So you get it as E cubed. Next question. Prove that determinant of B plus C A, B C plus AB, C A plus B is 4ABC. So if I do R1 minus R2 minus R3, the first row, this becomes 0. This is A minus C minus C. So minus 2C, the A gets cancelled. Again the A gets cancelled, you get minus 2B. The second and third row remain unchanged. Now, if we can take out the 2, we take out the 2 from which row? The second row. So you get 2, 0, minus C minus B, B, C plus A, B, C, C, A plus B. Now, if I do R2 plus R1, we get B, A and 0. Basically, we're trying to get at least 2 zeros before we can expand. So when you expand this, you get the answer as 4ABC. And how do you expand it? 2 into, this is 0, plus C into B into A plus B, and then you have 0 minus b into bc. So you get it as 4abc. Next question. Prove the determinant of x, y, z, x squared, y squared, z squared, y plus z, z plus x plus y is x minus y, y minus z, z minus x, x plus y plus z. So we do C1 minus C2, C2 minus C3. So I get x minus y, x squared minus y squared, y minus x, y minus z, y squared minus z squared, z minus y. The third column remains unchanged. So you can take out x minus y from the first column, y minus z from the second column. So you get here 1 x plus y. This becomes 1 y plus z minus 1, and the third column remains unchanged. Now to get some zeros, we can do C2 minus C1. So the second column becomes 0. You get z minus x 0, and the first and third column remain unchanged. Now we can expand since we have two zeros. So it is 1 into z minus x into x plus y minus 0 plus z into 0 plus 1 into z minus x. So ultimately you get your RHS, which is x minus y, y minus z, z minus x into x plus y plus z. Coming to question 4, prove that 1 plus a squared minus b squared, 2ab minus 2b, 2ab 1 minus a squared plus b squared 2a, 2b minus 2a 1 minus a squared minus b squared is 1 plus a squared plus b squared the whole cubed. So we have to keep looking at our RHS. I need to get a 1 plus a squared plus b squared. So how will I do that? I do r1 plus b times r3. So I get b times, this is your original determinant. If I do r1 plus b times r3, I get 1 plus a squared plus b squared, 2ab minus 2ab, which is 0, minus 2b plus b into 1 minus a squared minus b squared will give you minus b into 1 plus a squared plus b squared. The second and third row remains unchanged. Now what can I take out common? I can take out 1 plus a squared plus b squared common from the first row. So I get 1, 0 minus b, and the second and third row remain unchanged. Now to get some more zeros, I can do r2 minus a times r3. So this is 0, this becomes 1 plus a squared plus b squared, and this becomes 1 plus a squared plus b squared. And the first and third row remain unchanged. Now I can take out 1 plus a squared plus b squared from which row? The second row. So you get 1 plus a squared plus b squared the whole squared into this 2 by 2 determinant. And now you can just expand it. It is 1 into this 2 by 2 determinant minus 0 minus b into 0 minus 2b. So ultimately you get 1 plus a squared plus b squared the whole cubed. And what is this? This is your RHS. Coming to question 5, prove that a squared plus 1ab ac, ba b squared plus 1 bc, ca cb c squared plus 1 is a squared plus b squared plus c squared plus 1. So I will do, this is your original determinant. I'm going to multiply the first column by a, second column by b, third column by c. So you can take out 1 by abc to balance this. So this becomes a cube plus a squared b, a squared c, ab squared b cube plus b, cb squared, ac squared bc squared c cube plus c. And now you take out abc common from r1, r2, r3 respectively. So what do you get here? You get abc by abc, which cancels, and you get a squared plus 1 b squared c squared, a squared b squared plus 1 c squared, a squared b squared c squared plus 1. Now we have to keep looking at our RHS, which is a squared plus b squared plus c squared plus 1. And how do we get that? You do c1 plus c2 plus c3. So you get this as your determinant. You can take out a squared plus b squared plus c squared plus 1. And what will be left in the first column? 1, 1, 1. The second and third column remains unchanged. Now to get two zeros, you can do r2 minus r1, r3 minus r1. Basically, we try to get at least two zeros before we expand. So you get a squared plus b squared plus c squared plus 1. This is your determinant. And when you expand it, you just get a squared plus b squared plus c squared plus 1, which is your RHS. Coming to question 6. Solve determinant x plus a, b, c x plus b, a, b x plus c equal to 0 when x not equal to 0. Now what do we mean by solve? By solving means we need to find the value of x. So if I do c1 plus c2 plus c3, we get x plus a plus b plus c in the first column, and that is equal to 0. The second and third column remain unchanged. So what can I do now? Take out x plus a plus b plus c outside. So you get x plus a plus b plus c. The first column becomes 1, 1, 1. Second and third column are unchanged. Now how do I get two zeros? Do r2 minus r1, r3 minus r1. So you get 0 x a minus c, 0 b c, x equal to 0. And now when you expand, you get x plus a plus b into x squared equal to 0. So we have x equal to 0 or x is minus a plus b plus c. Now what is the condition given to us? X is not equal to 0. So your answer is just x equal to minus a plus b plus c. So we have discussed the properties of determinants and learned how to solve problems based on these. We have seen questions from the past year's board exams, and I hope this is useful for students preparing for the ISC and CBSE boards. So do subscribe to my channel for more videos and feel free to send me your feedback for any further help. Thank you.